Thank you. First of all, I would like to remind all team leaders to please take attendance because this class is very important. And at the same time, I have been tasked to do a very difficult job, which has to do with, taking you on some advanced Kubernetes concepts. Let me quickly share my screen. Okay. Let me know when you can see my screen. Can you see my screen?
Yes, I can see your screen.
Okay, great. So I have been asked to take you on some, concepts, some advanced concepts, and there are a lot of things. So I have tried to just to bring them down into, I was asked to take you on 7 things, but I have to break it down to 4 of them so that you can easily understand. First of all, I was asked to, discuss with you on the topic of config maps and secrets. What is config map, what is a Kubernetes secret, and so on. Then at the same time, we have the duty of, the duty of getting to be able to talk about, storage in Kubernetes, volumes, and so on in Kubernetes. Then I was also asked to talk about, security in Kubernetes. How do you secure your deployment in Kubernetes and so on? Also to talk about horizontal pod order scaling, and when it comes to managing your application, how do you do roll up and roll down of deployment? I intentionally removed that roll down and roll up because I remember in our last I think when we were having the last presentation, I took my time to explain some of these concepts to you. And the final one which is missing here is monitoring. And monitoring has to do with playing with, deploying Kubernetes clusters on Grafana, on, Kubernetes, deploying Grafana, Prometheus, and Kubernetes cluster, and so on. So that is like, the monitoring. So probably it's going to be part of your tasks for the weekend. You have to deploy Kubernetes cluster, and, in your cluster, you have to, do some monitoring and so on like that as attached to it. So that is it. Now, I'm going to start from the beginning. In this class to, assist in facilitating this class, I have created a Kubernetes cluster on AWS, EKS, and I named the cluster daas cluster. I have also provisioned access to the cluster. This is the cluster. And in this cluster, I am just going to quickly, reiterate some of the things that DACO has taught us. This is cloud-based Kubernetes cluster. Now, I'm not using KubeADM. And you can see I have my kube system there. I have installed, some add-on like, kube proxy, EBS CNI, core DNS, VPC CNI, and so on like that. Because these are what I'm going to use for my cluster. At the moment, there is no deployment on this cluster. And we are going to go through a story point, or let me say like a story-based approach to being able to, work on everything that's been here, that is config maps and so on like that. And do anybody have a question before I start, first of all? Hello? Hello, can you hear me?
Yes, not for now.
Not yet.
Okay, great. Sorry, I'm trying to gather momentum. Yeah, I've been tired. Okay, so now let's talk about config maps and config and secret. In Kubernetes, we have what we call config map, and a config map in what's it called? A config map in Kubernetes is basically similar to, how can I hide this guy? Sorry, I'm coming out to hide something. I don't know how to hide this. I'm coming out to hide this. I don't know how to hide it. Okay. Maybe I should just do it like this. Does anybody know? Can you see my zoom this thing on my screen? I cannot hide it.
Yeah.
Can you see this zoom options?
No, we cannot see it.
No, we can't.
It's disturbing my screen. Sorry, I cannot hide it. Okay, let me stop sharing and share again. Sorry, apologies for that. It's really, really disturbing me. Can you see my screen again?
Yes, we can see your screen.
Oh, great. So I can hide it now. Okay, great. So config map, just can you see this readme here? Config map basically in Kubernetes is just used to store what's it called? It's non-confidential data. And there are two ways in which you can store data in Kubernetes when it comes to, confidentiality, or you want to keep information in Kubernetes. The first way is using a config map, and the second one is using a Kubernetes secret. Now, what is the difference between a Kubernetes secret and a config map? The difference is that for for config maps, they store non-confidential data. That is something that is not confidential. That's what they do. And for Kubernetes secrets are usually used to store what? Confidential data. Another thing is that for config maps does not provide any option of probably, encryption or encoding the data that you store in it. So when you create a Kubernetes, a Kubernetes config map is basically in plain text, and which is basically in what? In key pair values. You get me? Key value pair, sorry. Now, how does a config map look like in a Kubernetes environment? To start with, I have a deployment here. I created a Kubernetes deployment, a service, and at the same time, an ingress controller. This does not matter. Just forget about the ingress. Just focus on what we have there. And I'm basically working with Nginx because I think that was what you worked with in the last class. So I'm following the same process. You all know what a Kubernetes deployment is, and a Kubernetes deployment allows you to, to provision as many replicas of your pod as you want. And this is the main thing about the pod. The main thing here is that for your Kubernetes deployment, for this particular deployment, I am deploying an Nginx image. So now I want to do something to make this class very simple. I'm going to duplicate this guy. I'm coming. Let me just create a new file here so that you can understand what I want to do here. Let me just go deploy new.yml. Okay. So now if you look at this guy now, this is still it's still the same deployment. There is nothing special. I just want to remove some things that are not useful at the moment. I'm going to remove this. I'm going to remove all this container volume mounts because I'm going to explain everything to you. I'm going to remove everything here as well. Now, this is just a pure deployment. We all understand what this is, right? This is just Nginx exposing the container port, specifying the CPU resource limit, right? Okay, great.
Yeah.
Great. So now I'm going to deploy this. Let me try and deploy this and see what happens now. Okay, so deployment new. Okay, so let me create a namespace, because right now, if you look at this place now, if I check my namespaces, I don't have any namespace for daas. So I'm going to basically create a namespace for daas. So once I create a namespace for daas, I should have a new namespace here, created 2 seconds ago. So everything we are going to do, we are going to deploy it inside this daas namespace. So the first thing we should try and deploy here is the deployment file that I just created now. This is the new deployment file. And now when you come here now and you go to deployment, you should be able to see that my deployment, and you can see that the pods are running just like 9 seconds ago. This is our deployment. Now, back to this screen that you have here. This is just a normal deployment. There is no secret, there is no config map attached to this. Now, imagine that, considering the fact that this is an Nginx, for an Nginx deployment, and we want to add some other Nginx configuration to it, which has just Nginx data. How do you do that? First of all, you need to create a config map. And here I have created a config map here. I'm going to explain everything in this place to you. Don't worry. First of all, what does a config map consist of? Forget about this. A config map consists of three things. In every Kubernetes environment, we usually have what we call API version, kind, metadata, and specs for pods, right? Are you there? Hello?
Yes, we are.
For deploying for what's it called? For config maps, we work with what we call these three and these four: API, version, kind, metadata, and what's it called? And data. Now, what do you mean by data? Config maps allows you to use data, or you can also what is it called? You can also specify what is going to be in that particular data that you want to use. In config maps, you can add as many data as you want. In this place now, you will see that I added, because don't forget I told you that what we use key value pair here. Remember what I said here? Key value pair. Here I added a data called nginx.name, and I gave it nginx.daas.ng, right? That is just the name I want to give my nginx server. Now, I now added an extra data that is called what? Default.conf. These are just config map. Config map is just to keep store on confidential data, maybe configuration files or anything like that. That's why they call it config map. Here, I am now adding some some default nginx configuration into this deployment. Into this configuration config map. So from what you can see here, this is just saying that okay, the nginx server is listening on this particular port. This is the location. What are the errors that you should throw, and so on like that. And where should you really go and find some of these errors? This is just a default nginx configuration. Now, this is what a config map look like. The interesting thing about a config map here is that if I create this config map now, let's go back now and create our config map. Let's go back now. Let's run kubectl apply -f config map. Okay, the config map has been created, right? Now let's check for the config map here. You can see this config map has been created, right? And if you describe the config map, you can see this is what I have in the config map. Two data, one is what? Default conf, and one is what? nginx.name. But this config map that we have just created now has not been attached to our deployment, because we want the details in this config map to be on our deployment. We want these things to be on our deployment. Now, how do you use a config map in a Kubernetes deployment? There are different ways you can use it. The first one you can use it is probably, you can use it inside a container command or argument. That's one. The second way is that you can pass it as an environment variable to the container. The third one is that you can attach it as a volume to the container. And the fourth one is that you can write it as well as you can write a code that will use APM, the pod inside the pod, and you can use call the Kubernetes API to read the config. Now, everything I'm saying is what you have on the right-hand side of the screen. But what are the most used cases? The most used cases that we have is what we call the second and the third one here, which is what? Having it as an environment variable, having it as as a file or a volume on your on your application. These are just the two ways you can have the most used ways of using config map. Now we have created that config map now, and let us now try to add that config map to this to this deployment. Now, the first method I'm going to try is going to be using it as environment variable. When you are using config map as an environment variable, the first thing you need to do is that there is what we call a when it comes to the the container specification, you need to specify the environment, then you need to specify the reference in which you are taking it from. Let us do it together. Not volume mount. env. Now, I am using I'm using GitHub Copilot, so it is smart enough to quickly predict what I want to do. Now, can you see this now? What I have just done here is that I have attached that config map that I created to my deployment as an environment variable. Now, in my config map, go back to this config map now. You notice that I have two data in this config map. Do you remember?
Yes.
I have two data, but I am only using the first one. I intentionally made two data because I want to just explain to you that you can pick as many as you want. You can have 4, 5, 6, 7, 8, as much as you want in a config map. But now I just want this particular config nginx.name. I need it in my container. Maybe I just want to attach it to my configuration, my default configuration for my for my container. So I need this environment variable. So now to use environment variable when it comes to config map, all you just have to go is under your containers, specification, under the container, create an environment variable, specify the name, and also specify the config map key reference. These three things is so important. These three things are what? So important. This is the only way you can do it. Now, when I'm picking my config map reference, what did I pick? I pick the name, Abi, which is the name of the config map. What's the name of this config map? The name is here. nginx-conf, right?
Okay.
And I am now picking the key in it, which is this particular data I want to use, which is this. So if I want to say, for example, maybe I create another data, for example, I can say I want to create another data, maybe nginx dot, should I say, let me just give it like a sub name or version. Okay, version, for example. And I say, okay, I'm using this version. I can pick this same data and mount it as another, what's it call it? Another environment variable to my, what's it call it? To my deployment. So let us do it like this way now. Yeah. Did you see that? So here I have picked nginx version and at the same time nginx config as what's it call it, as a host name, as what's it call it, as environment variables. So now let's try and deploy this. So to try and deploy this, let me just save this. I will save this. I have updated this. So I need to first of all redeploy the config map. So I'm just going to redeploy the config map here so that it can update to have the latest changes. You can see. So let's confirm that the config map has been updated. Okay, we have the version here now, you see? So now we have the version. Let's go and create the, what's it called, the deployment again. So now I have updated my deployment. So let us check if the deployment has been updated. So you can see the containers are now recreating, some are terminating, and all my containers have been recreated. Now, let's go into the container and look at if we have our environment variable that we have specified. Let's check it if it exists in the container. Now, I have logged in into my container now. If I run, the only way you can know environment variables in what's called in Linux terminal is just when you run env, and it will give you all the list of environment variables that you have. So if I run env now, I should be able to see my nginx, what's it called, host. Let's find it. This is nginx version. Did you see this? This is nginx version. And where is nginx host? You can see it here. Did you see that? So these are ways in which you can pass config map as environment variable into your Kubernetes deployment and can be used for a lot of things, like a lot of things. Environment variable are very, very useful. So this is an example. Now, let us now try, let me exit this shell, sorry. Exit. So now let us try the second method, which has to do with, what's it call it, using it as a file, that is mapping it as a volume. Now, this time now, let's say we want to map the, what's it call it, we want to get this default.conf. We want it to what's called update the default configuration of nginx into that pod or that deployment. How do we do it? To do this, what you have to do is that When it comes to volume mounting, there are some things that you need to specify. First of all, you need to specify the volume. And the second thing you need to specify is the volume mount part or the volume mount. So let's go here and do that. Am I under the right space? Tab sources. Yeah. So now we want to specify what's it called. We want to specify the what's it called, the Kubernetes volume that will be used by this pod, and at the same time, what's it called, that will also be what's it called, that will also be mounted. Now, to do that, we need to determine three things. The first thing that we need to, any question before I continue, please? I hope you understand what I'm explaining. Hello?
Yes, we are following. We are.
Okay, let me know you're following. So the first thing that we need to do is to specify the what's it called, the config reference that we want to use for our volume. That's first thing. Then the second thing, because I have done similar thing here, you will see that here I pick in the what's it called, the volume here. I picked in the volume here. I picked in this volume here, and at the same time, I now pick in the what's it called, the volume mount. This is the volume mount for my Nginx. You can see I call it Nginx volume. So these are just the two things I need. So let's do this and see how it goes. So now I come in here. Where is this guy? Okay, sorry. Volumes. And name Nginx. Not doing persistent volume. Copilot is smart, so it's just suggesting a lot of things for me. Config. Yeah, exactly. Good. So now,
Let's the volume spelling. I don't know.
thank you. Now, this is my volume. In my volume, I have given my volume a name, right? I have also said that, okay, for this particular volume, I want to use a config map for this my volume. What is the name of the config map? I'm picking the name of the config map I've given it before, right?
Okay.
Which particular item? Because remember, here we have 2 or 3 now. We have 3, what's it called? 3 data here. So I am telling you, which particular one do I want to pick? I'm telling you, okay, I want you to go and pick this key called what? Default.conf. You get me now? And put it in here. So now, once we have done this now, this is just a volume. It is not yet, there is no mounting for that volume now. So now, next thing we need to do is now to create a volume mount that can be used by that particular resources. So now let's come back here now. Now, here now, I have created my volume mount. My volume mount is telling that, okay, this particular volume that is defined below here, that's beneath in this place, take this volume, this is the same name, and mount it in this particular part. This is just what we are doing. So now let us save this and try. Let me just run the same command again. Deployments new and change. So we should have our pods. You can see our pods are recreating again. Running, one is pending. I don't know why. Okay, it's terminating. Everything is fine. Good. So now let us look at that, because remember we mount this as a volume. So by the time we go into this container and we go into this part, what it means is that you should be able to see this, a file called default.conf in this part, and you should be able to see all this information that you put here in that part, because it's a file. So let's try it now and see. Let's go into the container. Okay, I'm coming, Sabo. Just a minute. So now I want to go into this particular container and check it now. Remember the part that we are using here is, what do you call it? Is, where is the part here? etc/nginx conf.d, then default. So let us go to ls, let's see, etc/nginx, then conf.d. ls now, we should see a file called, oh, sorry. Okay, this is the file. You can see here. You can see this is the file in that location because I told it to list the file in this particular location for me. And now when you say, okay, let me cut, or let me read what is in that particular file, you can go there and say, okay, nginx conf.d default on this, and you can see we have exactly what we have mounted. So this can be used as a configuration file for our nginx deployment. So even in the real world application, you can pass configuration files to your, to your application by using config maps, either as either as a file or as an environment variable that is mounted into your deployment. So I can have your question now, Sabo.
Okay. My question is regarding the manifest file, the definition of the volume and the volume mount, the positioning. I want to get the volume. The volume is defined directly under the
Container.
specification.
Container. No, it's right on that container. See, did you see?
Oh,
Sorry, it's right on that specification with container. So we have specification, containers, then volume.
okay, yes, that's what I want to get. So the volume mount must be defined in the container itself, right?
Yes, volume mount is always within the container because it's the container that is using it. And the
Okay.
reason why we always have volume, let me explain something to you. In Kubernetes, we can have more than one container running, for example. Some people call it sidecar, some people call it init containers, for example. And your init container can be using the same volume as what your container is using.
Okay.
And the amount part may be different. Say, for example, if I create another init container here now, and I say, okay, maybe I want to pick maybe nginx version or something like I just want to pick anything. I can have a different volume mount for that same thing in another place, but using the same volume. You get what I'm saying?
Okay.
So that is it. Any other question from anyone? Please, is it too complicated? Ask your questions, please. So I guess we are good, right? Hello.
Yes, I guess we are.
You are the only one that's responding. Please, is anybody here?
Yeah, we are good.
Yes, we are good. We are very good.
Thank you. Now, an important thing as well is that when it also comes to volumes, a volume can be made to be immutable. What do you mean by making a volume immutable? To make a volume immutable, meaning that you do not want any, maybe accidentally, maybe your DevOps engineer or somebody accidentally just enter your container and edit one or two things in your container, in your volume. If you in your config map, by doing that, all you have to do is just to set immutable parameter in your in the config. So what I am saying here is this now. Once I am done with this guy now, I can still come here. Sorry. And set immutable to true. So once I set this and I deploy the same guy, everything will be fine. I hope you get what I'm saying. In that case, what happens is that nobody will be able to edit your your config map because you have set that immutability to be to be true. So that's another way you can protect your your config map. Now let us go to secrets. I guess I'm done with config map. Let us go to secrets. Do not save. Let us go to secrets now. In a Kubernetes secret, that's version 3. I'm still going to use the same guy. In a Kubernetes secret, what's now the difference between a secret and and a config map? I've explained to you that a secret is just a sensitive data this time. It can be password, it can be username, it can be SSH key, it can be token or anything like that. That is a secret. Now, for a config map, I told you that the basic syntax for a the root schema for a config map is API version, followed by your metadata, followed by your kind, and followed by your data. But for secret, it's a bit different. We can have two types of mapping. That is, we can have a data or we can have a string data. Let me show you what I'm saying here. This is config map. Remember this guy? We have data here, right? Now, if you look at my secrets now, look at the secrets now. This is also data. But now we can have this data as a, what does it call it? As a normal data or a data string. What do I mean by data string? And when do you know when you have to define it as a data or a data string? A data is used automatically when your secret is encoded in base 64. A data is used when your secret is encoded in base 64. But if you do not want to have uncoded secrets, that is unencoded secrets, in that case, you use a data string. Am I communicating? Hello?
Can you repeat the last statements again?
I'm coming again. I'm going to repeat it. I know it may be a bit complicated. That's why I'm trying my best to make it very easy. A secret, when creating a secret, you can have two types of map. That is your secret type. Let's put it that. I don't want to call it secret type. Let me call it secret resource. Secret resource. The first one is a data resource, and the second one is a string data. What is a data resource? A data resource is basically just an encoded data. So if you look at this place guy now, this guy, for example, I'm using data now, and you can see that I'm passing in TLS secrets into my, into my data, but this is encoded. Nobody understands what this guy is doing. Nobody understands what is here, right? This is encoded. But imagine a case whereby I do not want to encode it. I want it to be plain as visible. Let me show you what this file is. This tls.crt. Let me show you the file. This is the file here. You see this is the file. Does this not make sense? This is a certificate, right? In a case where I want to pass it like this, for example, in that case, it has to be a data string. A string data. That is, when I'm defining my secret here, I will define my secret here. Instead of data now, I will just put it as what? String data. And I can define it the way I want. You get what I'm saying? So this is what I am saying. Ctrl Z. Now, another important thing that, oh my God, what did I just do again? Just undo this. Another important thing is that when it also comes to secrets, there are different types of secrets. Number one type of secret is what we call, some people call it generic secret, some people call it opaque secret. So generic secret is just like, an arbitrary data, like an arbitrary type of secret. We have other secrets that are like, maybe for SSH authentication, for Docker registry authentication, for TLS and so on. These are the types. So depending on the type of secret you want to create, you need to automatically always specify the type with it. Now, back to my Nginx guy again. You remember this guy? This guy is an Nginx. Imagine that I want to add SSL certificates to this Nginx. An SSL certificate consists of what? A certificate key and a certificate file, right? Which are the two files that I've shown you here. This guy. This is the certificate, and this is the certificate key. .tls.key and tls.crt. This is the certificate, right? Now, we all know what's it called, SSL certificate means, right? Please, if you don't understand, please let me know. Hello?
I think I try understanding it, but it's a bit...
Okay, let me explain it to you. What SSL certificate helps you to do is that it helps you to protect your application. Let us go to this. Can you see my web browser?
Yes.
Now, if you go to this web browser now, this is my, oh my God, okay. Don't worry, I will always delete the AWS account. It's not a big deal. If you open this guy now, you can see, what do you see here? You can see a key here, a lock, and it says what? Your connection is what? Is secure, right? What it means is that if you check this, you can only see that what this guy is using Amazon certificates to secure this environment. So in that case, there is always what we call handshake, the TLS handshake between the request and the what's it called, and the server that is also responding to the request. I don't want to be too complicated. I'm trying to make it very easy for you. So now the same thing is happening to my Nginx guy here. I want this Nginx, for example, to be live, to be able to have access, because according to what I have defined here, if I had access to what's it called, daas domain, people can check the website from this particular URL. You get me? You can see the server on the internet. We just have to what's it called, create some records on the domain server, and that's all. So now, if I do this right now, my guy is not going to be safe because it's internet facing, right? And there is no certificate. So now I want to create a secret of TLS type to protect this application that I want to host, which is my Nginx application. How do I do that? To do that, all I have to do is create a secret of type TLS. What did I show you here? I said there are different types here, and TLS type is for what? Data for TLS server or client. That is it. So for my Nginx, for example, all I have to do is come here, create a secret, which is the secret I have created here, and specify just the type there. That's all. And pass the data I want to put it, because it is always going to be what? Key value pair. That is just it. Do you understand what I'm explaining? I should come again.
I think we understand.
Okay, good. So this is the secret. Now I can create this secret and and deploy this secret in the environment. So let us create the secret now. To create the secret now, I guess I have to go back to my shell again now. Where am I? Exit. Okay, so to create the secret now, I just have to go back here. Just run kubectl apply -f, then secret.yaml, because I've named the file. It's created, and here I can always come here to check my secrets. You can see my secret is what? Of type TLS. And if I enter if I enter YAML, you can see this is the secret file. This is those encoded data that I have here. It's jargons. Nobody understands it. Now, a side note is that when you create a secret, please note that by default, your secret is only encoded. It is not encrypted. There's a difference between encryption and encoding. Are you there?
Yes.
I hope this thing is not complicated. Please, guys, please let me know if it's too advanced. Please let me know. Hello?
It's not complicated.
Okay, great. Thank you. There's a difference between encoding and encryption. Encoding is when you just do some, what do you call it, some base 64 encoding. That's encoding, like this command now. This command that you see here. I intentionally create this file so that at the end of the class, I can send you guys this document. You can run everything on your own and understand. So if you look at this file that I have here, let me open this file again to you. This file here, this TLS certificate, this is this file, right? This is this file. Now, this is a pure data. This is a raw data. Now, this data now, to encode this data, all you have to do is just to run this file, this command, cut this and encode base 64 encoding. Let me do the same thing for you here. This is my Linux terminal, right? Now, imagine I want to encode my name. I want to create a secret and put my name. You get, my name is Nurudeen, right? I want to put that as an encoded data now. So I can say echo Nurudeen, right? Base 64. This is my name in an encoded format.
Okay.
So it's just like you're trying to protect it. So this is encoding. So if somebody that knows about encoding very well if you want to know that what is the meaning of this, all the person just need to do is copy this guy again, then do what? Echo, pass that name again back into it, and do what? Base 64, but this time you are decoding. Base 64 decode. You see, I'm passing -D, and this should always give you Nurudeen back. You see?
Yes, sir.
Oh, so this is really different from encryption.
This is different from encryption because this is encoding.
Okay.
So when it comes to encryption now, in this time, you are using a key to encrypt. What do I say? When it comes to encryption, you are using what we call an encryption key to encrypt your file. And the only person that can have access to decrypt that person is the person that has the key, the private key to that particular data. Just like you are locking somebody, you are locking a room, and the person that can have access to that room is the person that has the key to open the lock. That is encryption. Now, back to this guy. In Kubernetes, if you want to encrypt your data, because somebody can have access to your data, if you want to encrypt your secret, the only way you can encrypt your secret, which is an advanced and interview question, is that you have to encrypt your etcd, your data at the etcd level. That's what you have to do. But that is outside this course right now.
Please, I want to ask a question.
Okay, please go on.
With regards to command base 64, is that the only command to use to encode? And
They may better command, they may better base, but this is the most used one. Base 64 encoding.
Okay, 64 is the only, okay, it's the most used
one. Yeah, exactly. I use it all the time. So are we together?
Yes.
Now we have created our secret, right? I think we have created it now. Yeah, we have created our secret.
Sorry, I have a question.
Go on, please.
Okay, so when we were working on the assignment that we were given last week here, we were trying to do the web, the one for the web development. So when we were trying to create a secret for our MySQL, so we used, instead of using it as defining it like a file, we created it like using kubectl, create secret, generate the name of the password and everything like that. Our namespace. Is that like a good practice, or
yes,
we always do it like this?
Yes, if you remember the first class that Dapo said to you, Dapo mentioned that there are different ways you can create a Kubernetes, Kubernetes resources. He said you can do it imperatively and declaratively. Do you remember?
Yes, I do.
Yeah.
Good. Now, using command line, is it imperative or declarative? That's your command.
That's imperative.
Imperative, Abi.
It's imperative.
But declarative is when you write a YAML structure for it.
Yeah.
If you want to know how to do, let me show you. Let me just give you an extra tip today. kubectl commands. If you are doing, for anybody that want to do Kubernetes, what do you call it? Exam. This is a cheat for you. You can see here is the way you can define all Kubernetes resources imperatively. You can see here, this is just, what's it called? kubectl, this is creating a Docker registry, right? It's creating, this is a, what's it called? It's imperative, right? So you can do as many things as you want. You can see, you are creating cluster role binding, you are creating cluster roles, you are doing config. See, this config map that we created now, this can be done imperatively. You can see here, this can be done imperatively, but it is good when you know both imperative and declarative. Another thing is that imperative is easy to know, but if you understand declarative very well, it is an added advantage. Because in a large environment, when you are working in a large in a large infrastructure, the most important thing that you will do is that you always probably write Helm file. I'm going to talk about that at the end of the class. Just write manifest and deploy manifest. Your imperative skills will only come into place when you have to start doing some troubleshooting. Maybe they tell you, okay, quickly let us get the logs of that deployment. Let us get this, let us get that. You can quickly run, type some command on the CLI and it will help you to do that. Did I answer the question very well, sir?
Yes, you do.
Good. So now if you go to your secrets now, this is what you did. This is Docker registry secret, sorry. A generic secret. This is what you did, right? Hello?
This is what we did, yes.
Exactly. Now, my own secret that I'm creating now, which is my TLS secret, because remember this secret I'm creating here is TLS secret. I can do it imperatively using this command. This is secret TLS. You see, kubectl create secret, specify the secret TLS, put the what? The certificate file and the certificate what? Key. Do you see that there?
Yes.
Which is the same thing I'm doing what? I'm doing here.
Okay.
I hope you're on the same point.
Yes, we are. Thank you.
You're welcome. So now, I have my secret created. Please ask your questions. I really want you guys. I took my time to write these stuffs so that because it's difficult for me to just start explaining. I cannot be doing presentation slides for these things. So it's important that I try to carry you along. So ask questions, please. Just ask. There's no stupid question when it comes to Kubernetes, please. Ask your questions. Now, let me continue. Now we have this secret, right? Remember the difference between a secret and and a config map is that what? Is that one is confidential and the other one is not what? Confidential. You remember? Hello?
Yes, yes.
Respond, please respond,
Yes,
please respond.
yes.
Now, I want to mount this secret on my, in my environment. How can I mount it? The same way you can mount a config map is the same way you can mount a secret. That is, passing it as an environment variable, just like the way I did for my config map, that I did that what? Reference, this time I am referencing my what? My config map, but this time is going to be what? Secret key reference. I did the same thing here. Let me show you. Look at this now. Do you see my, my secret here? Where is it? I saw it now. I see it now.
Line 33.
Can I even see it? No, this is mount parts. I
But
want to put
I
environment.
think
Okay, I did not mount it as environment variable. Okay, it's fine. I did not mount it as environment variable. Okay, but the same thing you did here, you can mount it as environment variable. Just do the same thing, like just put like this, just like this. Put the name. Then maybe you want to give it nginx, right? And let me say secrets. CLS secrets. Then put this is the same thing. This is the same thing that we are doing. Just like you have done for config map, the same thing you are doing here. And when you do this, if you want to not use this method, you can go back to your default method. Control Z. So let me just take this out. You can go back to your default method. This is the other method, which is to mount it as a file. And to mount it as a file, you need to first of all mount that volume. This is the volume that I mounted. And when you mount this volume, then you need to go and mount your volume part here. You can see here, I mounted it at this place. Now, let us do the same thing here so that you understand what I'm saying. It's not complicated. It's very simple. Let us first of all define the volume again, right? Name. Nginx -tls secret. This is it now. In this place now, you will see that similar to the way we have config map, we are referencing the secret name for the volume. So in this my container now, I'm going to have two volumes, right? Hello. I'm going to have two volumes for these deployments, correct?
Yes.
One is for my config map, one is for my what? Secret. But now this secret needs to be mounted somewhere. And where is it going to be mounted? It's going to be mounted in the same place. All I have to do is just what? Put the name, put the name, and it gives me. Now, what do you see here that is different from the definition I gave for for config map? Is that here you will see that part of the options I passed to it is read only true. You can see, read only true. What it means is that by the time you go to that particular part, when you mount this guy, the permission in that part will be different. It will be more of read only permission. That is, you will not, I've taught you about permission in Linux environment, right? You'll not be able to write to that environment. So you only be able to read that particular file. So maybe your application, you may want to write something, you will not be able to write to that particular part because it's read only. It's also a best way, is one of the best security practices when it comes to Kubernetes secrets as well, config, what's it called it, and config map. So the same thing here, you can also put read only, can put it here as well, read only true. I can put it here if I want to. Am I making sense? Hello?
Yeah.
Okay, good. Thank you. So now let us mount our secrets. And see what's going on. So now we have done the secrets here. So I want to redeploy the application again. So this time we have our secrets attached to it now. So I just want to keep it here. Apply deployment new. Okay, good. So let's check the deployment again. Pods are creating, pending. It is there. Okay, good. They are all recreated now, right? So now let us go into that environment and go and see if that secret is in that file, just the same way we did for the other guy. There is nothing special. There is nothing special. So let us do, I want to show you something now. Let's see. Nginx. Now, this is my, what's it called, my XSL, right? This is my conf.d, right? So now let us now go to the SSL. Did you see this guy now? This is the secret now. Remember the secret now, guys.
Yeah.
Exactly. So this is it. Now we are done with that secret. Another way you can use secret, which is the most important as well, is using secret for image pull from private repository. I'm here, guys. I'm here. Can you see my cursor?
Yeah.
Yes.
Yeah, we can.
Now, what do I mean by that? There's no example for this, but I'm going to explain it for you. In this environment, when I specify the image, I go specify Nginx, right?
Yes.
And where is it getting the image from? Can anybody answer that question?
From public
Docker.
repository.
Public repo, correct. God bless you. Public repo, right? That is where it is getting the image from. Now, imagine you are in your company now, and in your company, they want to deploy applications, and all your applications, all your images that you have built is in your personal company, what's it called? Your personal company repository or artifact or registry. How do you tell Kubernetes that, okay, I want to give you access to my repository or my artifactory for you to be able to pull? Maybe we create a new image called, daas image. We want you to be able to do that. That is where this image pull secrets comes into it. Now, how do you do this image pull secrets? There are different ways you can do it. The first one, which is the most effective way, is that you need to create a, a Kubernetes secret of this type, Docker config JSON. What did I say? Docker config JSON. This is going to be a secret that has a, a username, password, and your registry URL. Do you understand what I'm saying?
Yes.
This,
Yes.
let me show you. I showed you something, guys, here. Okay, this is it. Let us look at it here. Docker registry, right? Now, what did you see that is asking for here? It's asking for Docker registry server name, right? Username, password, and email, right?
Yeah.
So
Yes.
if you are creating this kind of secret, this is what happens. So now, when you have this secret, when you are now creating your deployments in your what's it called it? In your container specification, you will now add a parameter called image pool secret, and you will reference that secret. What it means is that automatically that secret gives your deployment the permission to pull image from your private repository. Do you understand what I'm saying?
Yes.
Yes.
Do you understand what I'm saying, please, guys?
Yes, yes.
Okay, I'm going to give you tax. So, okay. Yes, I'm going to give you. So this is all about secrets and config map. Any questions? Okay, sorry. Another one. If you go to another security tip is this. If you go to my deployments, if you go here, that what I wanted to show you before. If you run cd/etcd/nginx SSL, right? ls-l. If I run ls-l, right? It should show me this guy, right? Show me my secret, correct? You guys know what this guy means, oh. I've taught you people symbolic link, oh. You people should know this, oh. Abi?
Yeah.
Better. Don't look like strangers, please. Now, this guy is here. But what if you want your secret to be hidden? That is until somebody run LA command, ls-la command, that the person will be able to see hidden files, in that particular, you'll be able to see your hidden secrets. How do you do that? That's a tip, extra tip. For you to hide your secret, all you have to do is that there is what we call where is that secret file again? Okay, this is it. There's what we call .file secrets. What you just need to do is just to put dot, and everything will go, which is what I've explained here, that you can make your secret hidden by defining a key that begins with what? Dot, or you remove the dot to make the secret what? Visible. So if you put dot here, that TLS will be what? Will be invisible. Should we try it, or we should continue? Because we have other things. Let's try it. Okay, so let us make one visible. Let us make the other guy invisible, right?
Yes, sir.
So let's deploy. Exit. Sorry. People should not use it tool I'm using, please. Don't use it, it will not make you know Kubernetes. So it's important.
You mean Copilot?
No, not Copilot. I'm not talking about Copilot. I'm talking about what I'm using for Kubernetes on the UI. That I'm not running commands. Secret. Sorry. What am I typing? Sorry. Apply /f secrets. Invalid, what's it called? Invalid data. What happened again? Require value. Have I not given it value? TLS the secrets now. Okay, dot in by. What's going on? Invalid value, blah, map dot. What's going on? Okay. I think I need to add dot file. I'm coming. Just a minute. I need to check this. Thank you. I think it's dot file. I'm coming. Kubernetes secrets hide. Let me see. I think it's dot file they call it. Just a minute. I just need to check. Dot file. Yeah. So dot file. Yeah, it should work. What is why? What is not making it work? Okay, because of the secret type. Okay. This is what I was showing you. Because of the secret type, I think that's why it's not going through. This is what I was showing you. So just put dot and it will fire. But I don't know why it's not working here. Let me try it again. Sorry, please. But if it does not work, then we can move to the next thing. Voila. But maybe most likely because of the secret file type. That's why. Let's try. So Control C. Yeah, it's not going. It's invalid. So I guess that's why. Because of the kind of secret that we're creating. It's not a problem. Okay. So Anyways, I've explained that to you. Any question? Any question? Any question?
Not for now, Jess.
Okay, good. Thank you. Now, we are leaving secrets now, right? Let us go back to, where were we? Persistent volume. Persistent volumes. Persistent volumes. I think that's slide 4. Yeah. Persistent volume. Now, I'm going to explain something to you today, and it's so much important that, you take this. I want to explain. When it comes to volumes or storage in Kubernetes, there are some keywords that you need to know. The first thing is you hear people saying PV, people saying PVC, right? People saying PV access mode and so on. What does it mean? What do they imply? Let me show you something. PV. Okay, good. Now, I intentionally commented those things because I want to explain something to you. When you are creating a Kubernetes cluster, for your deployment to work, or for your deployment, you basically need volumes, that is storage, right? For your deployment. And what does this storage help you to do? This storage actually helps you to, what do you call it? To persist informations on that particular pod, because once I delete a pod, are you there? Hello, can you hear me? Once I delete a pod,
Yes.
all the information there is lost, right?
Yes.
Hello.
Yes.
But if you have a volume persisted on that particular pod, even if you delete that pod, you can still go to that particular volume to get what you need. Is that correct? That is why we have this name persistent volume. That's why they call it persistent volume. Now, when it also comes to persistent volume, there's what we call persistent volume claim. Persistent volume claim basically has to do with how do you request for a volume that you have created. For example, I can create a persistent volume of maybe 50 gig. 50 gig is too much for one application, right? For example, Nginx is too much. What if I will have other deployments and I want them to use those persistent volume? In that case, every deployment needs to have a persistent volume claim. That is, it's like a request that, okay, give me this particular size of volume from what you have. That is what persistent volume claim means. Do you understand what I'm explaining?
Yes.
Good. Now, there is now what we call storage class. Storage class is nothing. The only thing is that it helps you to dynamically provision persistent volume. It does what? It helps you to dynamically provision persistent volume. What do we mean by dynamic provisioning? What happens is that most of the time, it is difficult for, if you are working in in a production environment, it's difficult for you to manually create persistent volume all the time. Because if you are creating persistent volume all the time, maybe you have to, maybe on AWS, you have to go and create the persistent volume, specify the volume ID or whatever. That's the way it has to be done all the time, right? But what if you want a volume to be, to be created dynamically? That is, once it is needed, there's a provisioner that is providing it for you automatically. Once it's needed, something is providing that volume for you. Once it's needed, once it's providing it for you. That is where storage class comes into. So storage class is just a way that allows you to what? To dynamically provision volumes. So there are two combinations. The first combination is that if you want to manually provision your volume in a Kubernetes environment, you need to make use of a persistent volume and a persistent volume claim. That is combination one. The second combination is if you want your provisioning to be dynamic, you need to make use of a persistent volume claim and a storage class. Now, what is a storage class dependent on? The storage class dependent on the provisioner. In Kubernetes, Kubernetes supports many types of volumes or volume types. Let me put it that way. Right now, I am working on AWS EKS, as you can see here, right? So automatically for me, I am using EBS volume. If you come here, if you come to pods, sorry, pods. Let me show you all my pods. You will see something called EBS CSI controller and CSI node. You can see these guys, right?
Yes.
These are the things that allow me, they are like custom resources. They allow me to be able to request for volumes automatically. So when I create a storage class and tell that, okay, from my storage class, so I create a PV, automatically it will be provisioned for me. Am I making sense?
Yes.
So that is the reason why you see me here, that when I was showing you this pvc.yaml, I intentionally did this. Now, in a case where I don't have that storage class that I'm using, that I don't want to use this storage class or anything like that. In that case, because right now, see, let me show you something. Let me show you something now. See, storage class. Do you see that storage class already created? Right? And it is what? 5 hours ago. The reason is that it's because of I already have that provisioner already there. So it has already created my storage class for me. It's not that I'm creating it manually because I'm doing dynamic provisioning. So when I'm using a storage class, if I do describe now, what you see is that the condition, the binding mode is that it will wait for the first consumer. That is, this guy will just stay here and wait for somebody to come and request for the volume. Pim. I'm going to explain reclaim policy. I'm going to explain for you. And you can see that for this kind of volume, what is the file system type? Extension 4. And the EBS type is GP2. If you go to Kubernetes, if you use, what's it called? If you use AWS very well, you know the different types of EBS. But this is just like a type. Don't let me complicate it for you. Go back now. So back here, if, for example, I don't have this storage class and I want to use combination 1, which is persistent volume and what? Persistent volume claim. In that case, I will go to AWS console manually, go and create a volume store. Then I will come back here and create a persistent volume and then attach the volume ID of the volume I have created. Am I making sense?
Yeah.
Am I making sense? That is, I am manually doing it. Now, in a case, so if I then, once I'm done with that, then I can now come here and come and do what's called my volume claim, my persistent volume claim, they call it PVC. But in my own situation now, okay, let's do this. Let's just do something. It's not a big deal. I'll delete it later. Control K, Control U. I'm gonna delete it later, don't worry. Let me go to AWS environment. I don't know if I should have access. Yes. Okay, expired. Just a minute. Dapo. Hello, Dapo, are you there? Please take this part out of the what's it called? Just blur out this part in the recording when you are sharing the recording on YouTube, please. We should not come and hack my lab environment. Okay, so now let me create a simple volume now. Just want to create a test volume. Let us create any volume. Let's just create like something of 10 gig, right? You can see volume type that I was telling you here. You have GP2, GP3, whatever. Let us use GP2, right? I just want to create this guy here and, apply, right? This guy here. Created. You see it's created, right? Now it's in creation mode. So it's available, right? You can see it's available, but not in use. So now let me pick this guy now. Come here, copy the volume, and go back here now. Put the volume ID. Control V. Right? Control S. Let me take this guy out for now. Control K, Control C. So from what I have here, now, from what I have here now, can you see this guy now? From what I have here now, I want to create a persistent volume, right? Now, from here now, I can go back to my, what's it called? It's my terminal. Where's my terminal again? Let me put this guy again here. But before I do that, if you come here now, come to PV, there is no persistent volume. Do you see that there's nothing here? Now let us create a persistent volume now. Created. What do you see here now? My persistent volume has been what? Has been created. What? 5 gig. Do you see?
Yes.
Good. So if, for example, I want to make use of this persistent volume for my, what's it called, for my resources, then I can now create a persistent volume claim to use information. So if I'm creating my persistent volume claim, I'm not telling that, okay, this claim will give me maybe 5 gig from what you have, or maybe give me 2 gig from what you have, or maybe give me this from what you have. That is what this claim is about. You are requesting. But now I don't need this guy because my volume provisioning is dynamic and I already have a storage class name. All I just need to do is just what? Specify the storage class and it will create the volume for me, the volume claim for me automatically. So now back, I'm removing this guy now. So back here now, sorry. Let me delete this guy. So now back here now, I want to now create my persistent volume claim. Now, to create my persistent volume claim now, we go back here. Run the same guy again. Persistent volume claim has been created. Now, you can see that there's no persistent volume here. Do you see? But if I go to persistent volume claim, I should have a persistent volume claim. Do you see? Now, what do you see here? You see the status is what? Pending. That's how I want to explain to you. Pending. And you can see that it is referencing what here? It is referencing a storage class GP2 because that is what is helping us to provision it dynamically. Do you remember? Now, why is it pending? Let us describe it. What did you see here? Waiting for the first consumer to be created before what? Before binding. That is, this volume is there now. Nobody's using it, so it's pending. Once we have a container that is our pod, because there's nothing in our pod now that says that, okay, we want to make use of persistent volume. Do you have anything here that makes use of persistent volume? No. So there's nothing here that is making use of persistent volume. So it's going to be pending until it has the first person that what? That requests for it. Now, why is it that it has to wait for this? If you go back to my storage class, in my storage class, if I describe the storage class for you, what's the binding, volume binding condition? Wait for what? Wait for what now?
First consumer.
For first consumer. Now, another important thing is this now. When you are creating a persistent volume or persistent volume claim, there is what we call access mode. What do I call it? Access mode. This guy is very important. We have 4 types, not 3 types. We have 4 types. The fourth one is still like in process. So let us focus on 3. We have read write once, read only many, read write many. What does it mean? It is simple and straightforward. Remember that I told you before that when you have a persistent volume, it's just a volume. Containers can claim as many as they want from it, right? Hello? Hello,
Yeah.
guys.
Yeah.
Hello,
So, from what we have here, read write once means that what? The volume can be mounted as read write by only one what? One node. That is, this volume can be routed as by only what? One node. In my Kubernetes cluster here, I have 2 nodes here. I have 2 nodes here. You can see. These are the 2 nodes I have in my Kubernetes cluster. So this volume, for example, can be claimed by only what? By one node. So how do we get to know which node is claiming this? If you go on kubectl there, what's it called? kubectl get pods and probably do node wide, you should be able to see where your pods are running. So you get me now. Let's try it. I'm coming. Where is the guy again? Look at it now. Do you see all these guys? This deployment, daas, right? Where are they running? They are all running on one node. Do you see they are all running on one node? Look at the IP address now, guys. 10.0.3.74, right?
Yeah.
Yes, we are seeing it.
So that is to tell you that this condition here is being what? Is still fulfilled, because in my PVC claim, I put what? Read, write once. The second one is read only many. What that guy means is that the volume can be mounted as read only. I mean, as read only by what? By many nodes. That is, many nodes cannot write to it, but many nodes can read to it. The final one is read, write many. Can mean that what? It can be read and writing, I'll be written to it by many nodes simultaneously. It is just access mode. How do you access something? That is it. Another one. Are you guys with me? Are you guys with me? Are we together?
Yes, we are.
Good.
Yeah.
Another one is what we call persistent volume reclaim policy. This guy. We have, I don't know. I know about 2, to be honest. I don't know. I know about 2. We have retain. We have delete. Let me check it. Sorry. It's not big deal. We can check it together. PVC reclaim policy. Reclaim policy. This is. Where is it? Okay, we have 3. You see? We have retain, we have recycle, we have delete. Retain means that when that persistent volume can be reclaimed by another, can be reclaimed by another pod or whoever needs it again. That is if it is no more in use. You get me? That is retain. Recycle means that it will delete everything. You can see rm-rf here. Did you see here? It will delete everything in that guy and can still be used by another person. It's another deployment. Delete means that once you are no more using it, it is what? It is deleting automatically. And this is usually used in what? AWS, EBS. So here, what if I want to do it dynamically? What will happen? Because for dynamic, I am using what? I am using storage class, right? Hello? You guys are sleeping. Are we together, please?
Yes.
For dynamic, we are using storage class, right? So that means in my storage class, there must be a reclaim policy defined in it. So let us check. Let's go to the storage class. Storage class. Let us describe. What do you see as the reclaim policy? Delete. Do you see that?
Yeah.
So that is it. So these things are very important. These things I've highlighted here are so much important. Now, let us create, don't forget that we have just created the PVC. We have not mounted it to our container is not using it. Nobody is using it so far. Remember now? So I'm just going to use this deployment now because I think it's complete. This deployment is complete. I'll just use this guy. Now, what is in this guy is this, the same thing. Remember, we have done this before for what's it called, for config and what's it called, secrets, right? Now, this time, I'm now adding what we call a new volume. but this time it is coming from a PVC, consistent volume claim, which I have created already, which is here, right? Now, it is creating a new volume, is mounting this volume in this particular part, daas.ng. There's nothing there, it's just empty. So maybe, for example, that place is so much important to you. Maybe you want to be keeping application logs there, for example. That guy is going to be there. And you can be writing to it. Even when your container is deleted, another person can still pick it and still use it. That is it. So let us just run this guy and we should be good. I don't think there's any other difference here. There's nothing. Okay. So let us run and we'll be good. So I will just go back again now and run kubectl apply -f deployment.a. Sorry, not this one. So now let's see my containers. So my containers are recreating. Let's see what is going on in this guy. I want to show you something. Please, it's so much important. It's so much important. Very, very important. Let this guy finish. I will now show you something. Remember that we have the guy, the PVC, in a particular, what does he call it? This guy. We have it in pending state before. What do you see now?
Oh, yes, it's not been
bonded. It has bonded. And when you see it now, you can see what? Successfully provisioned, blah, 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 right? It waited for the guy to come. Abi, when it waited for the guy to go, use an external provisioner, which is and was claimed by this what? For this particular claim. And you can see here, you can see that everything that you're doing, you see this EBS CSR that is doing it for us because it is what we are using as the controller to do this thing. So it has bonded. So my deployment should be complete now. Everything should be fine. Someone is still pending. I don't know why it's pending. Let me just check this guy. I don't need it anyways. I just want to check why it's pending. Okay, toleration, taints and toleration. Okay, this is just node affinity or volume affinity. So it's none of my business. I don't need it for now. So, but I've just shown you the most important thing that you need to know. Okay, good. We are done on what is it called? On PVC, right? And PVs. Any question on this? Please ask your questions, please.
Yeah, I think for me it is a whole lot, but I believe maybe
Exactly.
all over we can be able
Exactly. That's why I am taking my time. Like you can see that I have readme for you so that when you don't understand, you can still go back home. I will what's it called? I'll push this to daas repository. You people can copy it, you can reference it. And even for the cluster creation, the Kubernetes cluster, I created a file for it here. You can see this is everything that I used to create my cluster. This is the cluster creation. You can see this is the EKS file. So people that still want to just say, okay, let me just copy what Nurudeen did. You have everything here. Just copy. Just deploy it. We do it for you. I created my cluster using Terraform. You can see the load balancer controller. Everything is here. So you don't need to do anything. Just copy, place. It will replicate everything I've been doing for you. So any question again on PVC? Because I will finish this thing today. No matter what you want, I will finish it today. Please, do we get that?
I think it's something we would digest better if we sit to go through it.
Yeah,
Definitely. I agree with you.
Yeah, that's
I agree with that. I agree with that. Okay. So now let us now go to security. We are already in the simple part, don't worry. Security in Kubernetes. Now, when it comes to security in Kubernetes, there's what we call RBAC, role-based access control. And it's so much used in Kubernetes environment today. When we are talking about RBAC, we are basically talking about 4 important things. We are talking about what we call cluster roles. We are talking about role. We are talking about role binding, and we are talking about cluster role binding. Can I come again?
Yes, sir. Come again.
Yes, please.
We are talking about, please, if you are still in this meeting, please let me see you type Y on the chat, please. If you are still in this meeting, I want to know people that are not in meeting, please. Let me see you type Y. So just drop Y on the chat. We are talking about cluster role. We are talking about cluster role binding, We're talking about row, and we're talking about row binding. Now, what do I mean by that? It is not difficult. It's nothing. Don't think too much. It's nothing. Nothing. When you hear the name row, a row is just a set of permission that is applied within a namespace. Can I come again? I think there's something I need to be doing for this guy so that it can be better for you people to pick it up. Where is that? Coming. Where is it? Set of permissions. Set of permission that we have within a single space. Now, so a row is just what? A set of permission that's applied between what? A single namespace. That is a row. What about a cluster row? A cluster row is also a set of permission, but is applied within the whole cluster. This is what I'm talking about. Cluster row is a set of permission that's applied within what? Within the whole cluster. Guys, are we together?
Yes, we are.
Are we together? So, if you look at this, my fine guy here, back that you see here, this is a row. What? How do you know that it's a row? First of all, you can see that it is applied within the namespace called what? DAS, correct?
Yes.
And what is the permission that is seen here? The permission is that it is giving, this row has the permission to get, watch, list Kubernetes pods in that namespace. Because it's always within the namespace, right?
Okay.
So that is a row. Let us now go to my environment again. Let me go for rows, not row binding, row. You can see that there is no role in my namespace, right? Now, but if you go to other namespaces in this environment, you can see that there are this another namespace, kubectl public, kubectl, kube system public, kube system and kube public. Now, let me say, for example, I want to check maybe a row called EKS metric, for example. You can see that this row has the permission to get daemon sets, to get deployments, and to list config map. Are you with me? Hello?
Yes, we are.
Yes, we are.
Let us pick another guy. Let me go manager. This row called EKS node manager has permission to what? To create config map, to list and get events, to also what? To also get, update, and patch config map called AWS auth. This one is limited to config map, a particular config map. That is, for example, this row cannot do anything on any other config map except this guy. So the config map that I created, that we called nginx config, this row cannot get it. This row, that is anybody assigned with this row cannot get that part, that config map, cannot update that config map, or cannot patch that config map. Are we together?
Yes, we are.
Now, let us go to cluster row. Cluster row, like I told you, is always applied what? Within the cluster, right? Let us look at admin row. This is admin row. What did you see? He has every permission in this word. Did you see? Admin can do anything. Anything. Did you see all the permission? To any resources here. Let us look at another one, AWS node. This is cluster, but this guy also has some words to get namespace, to list pods, to list node, and some custom resource definition and endpoints. So that is a row, that is a what you call it? That is a cluster row. Do you understand the differences between cluster row and row, please? Guys, please answer me.
The difference, I think based on your explanation now, which I guess I got it. Cluster rule is applied within the cluster. Why rule?
Yeah.
Why rule is applied to the, let me say, for instance, the pod generally, access to the pod generally.
Okay, God bless you. No, role is applied to the namespace. It's limited to
Okay.
namespace. This is what I explained here. Now, what is now a row binding? A row binding, are you there? Is just
Yes.
when you are now giving somebody that row that you have created. You are binding from the word row binding. So if we have somebody called Sabo, if we give Sabo a row called maybe a row that allows him to list pod, Sabo will be able to list pod by binding in together. That's what we call a row binding. Are you there? Cluster row binding is just by binding cluster row to a particular person or set of user. Are you with me?
Yes, we are.
Guys, please, are you with me?
Yes, sir. Yes.
Now, there are now several combinations. Sometimes people do cross multiply. They can do cluster row plus row binding. They can do row plus cluster binding. This is what I'm talking about here. We have 4 combinations.
Okay.
When you have a cluster row plus a row binding, when you have what? A cluster row plus a row binding, that permission will only be limited to its namespace. Are you together with me? When you have a cluster row, because a row binding will always have a namespace, don't forget, right? So when you have a cluster row plus a row binding, it will be limited to a namespace. When you have the second one, when you have a cluster row plus a cluster row binding, it will be the whole environment. That is the whole cluster. Sorry, the whole cluster. I said the whole environment. The whole cluster. Are you with me?
Yes.
The third one, when you have a row and a row binding, it will also be what? It will also be the particular namespace because it's normal namespace. When you have a row and a cluster row binding, it is invalid.
Okay.
Why? Because a row is limited to a namespace, but a cluster row binding is limited to the entire cluster. So it will be an invalid combination.
Okay.
Guys, I am explaining these things to you. Are you with me?
Yes, yes, we are.
Yes.
Yes.
Ada, are you there?
Small.
Yes, I'm here.
Oh.
Abdurrahim, are you there?
Yes, sir.
Okay. No, Allah. Fumilayo, are you there? Fumilayo is not in the meeting. Okay. Thank you. I don't mark attendance. It's okay. So you understand what I've just explained, right?
Yes.
I'm here. My sister.
Okay.
I'm here, please. My system was my second screen just went off. Sorry.
Okay. No Allah.
Yes.
It's fine. No problem. Dayo Kelani, are you there? It's not here. Patience, are you there?
I'm right here.
Okay, good. There is this my fine guy that used to disturb me. Emmanuel, is he in class?
There's a bot.
What's the bot? Hello?
I'm finding it hard to, understand the whole thing, but I'm just going to rewatch the video and...
Yeah, sure. That's why I'm trying to make it very easy for you. I'm trying to explain with readmes to guide you.
Thank you.
Now, Let us go back to our Nginx because everything that I'm using is Nginx. I'm not complicating things. Let's go back to our Nginx now. For this Nginx, guys, remember that I want to now give this Nginx permission. Now, this time I don't want to create a user. I want to create a service account. This service account, I want this service account to be able to list pods in that particular namespace. So since I'm talking about namespace, you know I'm creating a row, right?
Yeah.
Yes.
And at the same time, I am going to create a row binding. So you can see here that I have said that, okay, this particular role that I want to call Nginx role, this is the set of permission that should be there. How do I bind it together? To bind it, I need to say that, okay, in the binding, who am I binding it to? I am binding it to a service account called Nginx user, which is here. And I am binding what to that service account? I am binding this row to that service account. Are you with me?
Yes,
so
we are.
The way you can bind to a user, can bind to anything. Can see? What did you see there? When you see the highlight, it said values defined in the API group are what? User, group, and what? Service account. So you can bind your row or cluster row to a user, a group, or a service account. So now let's run this. Now I have my service account created, my row created, my row binding created. Let's go. Let us go to rows. That's row. Do you see that guy? If you create that row, what did you see? It has permission to do what? Get, watch, and list what? Pods, right?
Yeah.
Good. I will give you one simple test now. We have another one called row binding. What do you see it here? It's binded to what? A particular service account called what? Nginx user, right?
Yeah.
And what's the particular role that you're binding? You are binding this role to it.
Nginx role.
Nginx role. God bless you, sir. Now, sometimes in your environment when you are working, people want to confirm. I don't have permission to this cluster. I don't have permission to that cluster. I want to know what's wrong. There are simple commands in which you can use to know if somebody can really do a particular permission or can really carry out a particular action in your Kubernetes environment. This command is called kubectl auth can I. So let us do something, a test together. You can see this command here. I'm putting it here. I want to validate if the service account can access the pod. Did you see what I wrote here?
Yes.
Good. I have a question for people before I run this command. This is the command. Let me clear my screen. Sorry, let me put it here. This is the command, right? Guys, this Kubernetes is saying that kubectl auth, can I get pods, Abby, as who? As a service account called Nginx user, right? Because remember that when we created our, what does it call it? Our row binding, we created a user, our row, we created permission to, what does it call it? To be able to get list or what? Or watch pods. You remember, right?
Yes.
Come back here, row. Not row binding, row. If you describe this, you can see get, watch, or list pod, right? Yes. Now, this command now, we want to use this command to validate if I can actually do that thing as a service account called what? Nginx user. The response will be yes or no. So I am asking you, please drop on the chat. What is going to be the answer? Is it going to be yes or is it going to be no? Please drop on the chat. I'm waiting for you. I'm waiting for you. I want to see what you're dropping. I want to see what you're dropping. Just 5, 6, okay. 7. Luadamilola. Abitayo Idowu, sorry. He said yes, yes, yes. There's someone called Ola in this boot camp. Is the person on call? Okay, some people are saying no, 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 no. I think it's yes too. Okay, for people that said no, Patience and Daniel, why do you think it's going to be a no? Hello? Hello?
Yes, sir. Yes, sir.
Why do you think it's going to be a no?
Well, I feel because we're looking at the authentication there, and I feel let me zoom my screen. I'm looking at the authentication there, and I feel okay. It's asking, can I get a port as a service under service account of the image under NGX users? And I feel the output will be no, because I really can't explain it. But I've seen something similar like this.
Explain anyhow. Okay, Patience, can you assist him? You also said no.
I don't really think I can. I don't really know how to explain it as well, but authenticate, can I get poured? I believe it will be no. I believe.
But we have given this user that permission now. Okay, you are correct. That's not going to be no. Now, why is it no? I'm going to tell you by giving you this response. Do you see the answer now? Yes. Do you know the difference?
You didn't specify the namespace.
God bless you. God bless you. That's it.
Okay.
Because that permission is limited to a namespace.
Namespace.
Because it is limited to a namespace. So when you are doing something, you need to be very careful. We created a row and we limited the row to a namespace. But now, because you did not specify a namespace, it's going to be checking it in the Kubernetes default namespace. And there is no row called nginx in Kubernetes default namespace, right? Everything we have been doing is been in daas namespace. So this is very important. Don't lose this. Okay? So thank you for participating in that. So
thank you, sir.
You're welcome. Thank you for your suggestions as well. So for people that have said yes, if they are probably looking into the namespace, they'll say that, oh, namespace should be added there. And for people that said no, they didn't know the reason, but they just feel like, let me just say no. But that is just it. But if it was a cluster-wide permission, it would have been different. Are you with me?
Yes.
It would have been what? It would have been different. So you need to be able to distinguish this guy together. Let me show you something now. I am a cluster guy now. I don't want to put this guy now. Let me show you something. My name, in my cluster now, they know me as EKS admin, whatever, in this cluster now. Let me run the same command now. This is for myself. What's going to be the answer? I'm not putting pod there. I'm not putting anything. What's going to be the answer? For myself, I'm not putting as somebody. It's going to be yes, because I'm admin. I showed you admin has all their permission now.
True, you're an admin, so
yes. So even if I put a namespace here, it's going to be yes, because I'm admin. Do you get what is going on, please?
Yes.
Do you get what is going on, please?
Yes.
How do I do I'm admin? Let me give you an hint today, extra tip. There's what we call group. I created the group here called, where is the group again? Oh, this is group. You can see this group, they call it system masters. And you have cluster admin binding there. You can see this is system masters. This system master is a group. And as far as you're a member of this group, you have all the cluster what's it called, cluster row bindings as far as you're member of this group. So how do I map myself there to it? Like there's a config map that I have here that is called AWS auth. Where is it? Where is the config map? Okay, this is AWS auth. Here, I added myself, EKS admin, to this group called what? System masters. You see? So this is the role I am assuming now as a user. So EKS admin automatically has what? All the permissions of a system master. Do you get it? So it's an extra tip. Oh my God, I closed that. So it's an extra tip. Now back to our slide. I've explained row binding, I've explained this. Let us now talk about the last one. The last one I think is horizontal pod autoscaler. We are almost done. Thank God I'm even able to finish with time today. Now, what does horizontal pod autoscaling? I've explained it in the last class. I talked about it. Sorry, during your presentation. Horizontal pod autoscaling basically just helps you to be able to scale up your pods based on particular metric that you are watching out from HPA. Now, what do I mean? You always need to have a target reference when you are doing your horizontal pod autoscaling. And this comes in place when there is need for, when there is need for, for, I don't know what it is. Just a minute. When there is need for, scaling out your deployment, when there is high, traffic or high request, this is when this comes in. So here I have tried to create an horizontal pod autoscaler. You can see that the API version here is autoscaling version 2, right? At the same time, you see that what am I targeting? I am targeting a deployment called what? Nginx. Did you see? Hello?
Yeah.
Good. Now, I asked a question the last time. No, it was not you guys. 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 I was not you guys. It was an interview that was interviewing someone. Okay, it was not you guys. In this place now, you can see that the replica set is what? 1. Minimum replica set is 1, right? The maximum is 5, right?
Yes.
Good. That is to tell you that if you are scaling this guy, the minimum you should go to is 1. The maximum you should go for is 5. Based on what? Based on the CPU resources of that particular deployment. And telling you that once the CPU, average CPU utilization is 50%, my brother, scale up. Do you get that?
Yeah. Okay, sir.
That's what it means. This is just a simple distance. Now, if you want to now go complicated, you can add other things there, like stabilization window. You can add as many things as you want. You can add it there. But this is basically what the way horizontal pod autoscaling is. So let us deploy this and let us see. Unfortunately, we may not be able to test it out, but at least let's try something. Horizontal pod autoscaling, HPA. Okay, so now let's try it out. Do you have any question, please, on horizontal pod autoscaling? You can see horizontal pod autoscaling deployed. Come here, HPA. You can see I have my horizontal pod autoscaling deployed. Replicas what? 0. They're still trying to get the CPU resources information. You can see current CPU utilization does not know right now. Still trying to search for it. So you get now. After some time, it will get that data. So you get me. And you can see here, now we have what? 3 replicas, because that is what we have in the, in the deployment already. In our deployment.yaml. Do you see this place? How many replicas did I specify here? 3, right?
Yes,
So
sir.
it is telling you that right now I have 3 replicas and this. But when the auto scaling now comes in now, if I am able to, because my distance is not exposed, if I go to services, for example, services, there is Nginx service at this particular cluster IP. You see this cluster IP? right? If, for example, I'm able to configure my environment and other thing like that, I can do A/B testing. A/B testing is what I mentioned here. That is, I can tell that, okay, send this particular number of requests. So you get me now? To that particular application, depending on whatever port that it is. So with that, we will need to watch the, what do you call it? This is sending 1,000 requests to. If you run, so if everybody has it on their system, there is nothing special about it. Control L, AB, --L. You can see it's saying that what? N is number of requests, right? C is the concurrent multiple requests to take at a time. So it's basically AB, put the option, then push the host name and the path that you want to spend, you want to, what you call it, you want to send requests to. So this guy is just basically, it's just like a way of saying that, okay, what I show you here, just okay, send 1,000 requests with 50 concurrent requests at the same time to my deployment. They use it in doing noisy neighbor tests in the environment very, very well, but there are applications that they use for this, not running manually. So this will send as many requests as possible to your pods, and your deployment over time, the utilization will start to start to increase over 50%, and this guy now starts to behave accordingly. Do you get it? Do you get it?
Yes.
So, but now we cannot do that because this my guy is not exposed. I've not done a lot of things. Supposed to be exposed. I'm supposed to put the host name and some other things like that. So that's why I have this now. Another thing is that then when you are doing horizontal port auto scaling, if you want to make it very okay, you can add what we call scale down, what do you call it? Scale down behavior. You can see scale down behavior, scale down stabilization window. Stabilization window basically means this. I think I explained it in, well, not you guys again. Okay. Stabilization basically means that if you go back here, for example, imagine if I have a lot of requests, right? This guy will scale up, right? Let's say it scales to like 5. Are you there?
Yeah.
It scales to last 5, right? Now, if it is going to scale down, it's also, was you guys I explained to now, when I was talking about minimum surge, maximum surge last week for deployment, remember? Oh God. This guy that was saying this, coming. Deployment. And that's, remember when I was talking about this guy? Where is it? This guy. Remember when I was saying this? Remember this? Hello?
Yeah.
Remember I was talking about this on Friday? That was saying that minimum unavailable, maximum unavailable says that, the minimum when it's doing updates, right? When your deployment is updating, what's the minimum that cannot be unavailable? What's the maximum that can be unavailable? Which is what exactly we have at the moment here. Here we specify that 3 pods should be running, right? But now we have 4 at the moment, right? Because it's just like 25% of what you have. So stabilization windows is similar to what we have in the sense that for stabilization window, this time you specify seconds, saying that if this guy goes beyond 50% and you have scale up, or let me say it goes beyond 50%, how many, and you have scale up, and now it now goes below 50%, how many minutes should you wait for before it stabilizes? Hello, are you there?
Yeah.
That is what it means. That is, maybe it's going up and down, up and down. You need to give it some time. It's just like when you want to do alert. You say, okay, let this alert run for 30 seconds before you take action. Do you understand what I'm saying?
Yeah.
So that is what stabilization window is. And another thing that we have here, we can also have scale down policy and scale up policy as well. They also add it to this. That is just like adding more complications to it. But this basically do the job that you want. Any question? I'm done with my presentation. Any questions? You guys are sleeping.
Sir, no question from my end.
We're not sleeping, sir. We're just trying to comprehend a lot, sir.
We just have to go by it.
You have to go over it.
That's the thing, sir. We just
Yeah,
have to.
definitely. I agree with that. I agree with that. Is Emmanuel able to concur?
You might actually have more questions when going through it.
Okay. So this is what I would advise you people to do. My advice for you is that, hello, Dapo, are you there? Hello? Dapo,
Yes, yes. I'm here.
Okay, you can stop the recording. We are done.
Okay.
Okay. So my advice for you is this. My advice